Quadric Surfaces Part 2. We're going to look at these hyperboloids of 1 and 2 sheets. Unfortunately, these equations don't always come to us in this simplified format. Suppose we have x squared plus y squared minus z squared equals 1. It would do us a favor by putting it in this form. Generally, in this form, we have all the squares are positive, separated by an equal sign. And then we put the 1 with the 2 squares, and that can help us identify whether it's 1 sheet or 2 sheets. So in this case, we're going to move z squared over here, 1 over here, and it really gives us z squared equals x squared plus y squared minus 1. And it is 1 sheet, and it's going to be centered on the z-axis, just like the one we drew. Now in this case, we're going to move these 2 to the other side and leave the 1 here. You can solve for x squared equals y squared plus z squared plus 1. Just move these 2 over here. And guess what? It's 2 sheets, except for it's going to be centered on the x-axis. So you have those 2 pieces on the one on the positive x-axis, one on the negative x-axis, in front of the board, into the board, so to speak. And so now in this case, you'd want to move the x squared over here, the 1 over here, and we have x squared equals y squared plus z squared minus 1. And looks like it is 1 sheet. And same thing, centered on the x-axis. It's that it kind of looks like a nuclear silo. It would be centered on the x-axis, like if the x-axis were lathe and you were spinning it and turning the solid. Okay, in this case, let's see. Both these want to move to the other side. Keep the z squared here. Z squared equals x squared plus y squared plus 1. That's plus 1, it stays there. And let's see, that looks like 2 sheets. And centered on the z-axis. So, okay, one more thing. Basic transformations. This is really a pre-calculus concept. But let's take a basic hyperboloid of 1 sheet. That's number 3 right here. What do we know about that? Hyperboloid of 1 sheet. And you could even draw a rough sketch of what's going on. There's x, y, z. Looks like that. Several different transformations we can apply. If you take z plus 1, substitute for z, this makes it go down 1. It just shifts the whole thing down. If you substitute that makes it go up 1. If we substitute for x or y, or possibly both, that makes it go plus 1 along the x-axis. Okay, it does when you substitute minus, it ends up going positive. When you substitute positive, it ends up going negative. And that's true for all of these. Now, if you add 1 to this, that in effect is the same as substituting z minus 1 for z, putting a 1 over here. That plus 1 makes it go up, but z minus 1 substitution also makes it go up. You really need to look at these transformations as a substitution if you want to understand how it works along any coordinate axes. Okay, that's part 2. We'll be back with part 3, cylinders, in a short while.